Okay, this is the 10.6, 10.7 formative solutions. Make sure that you get the equations down when you don't have them, because it's useful. You got to make sure you identify the shape and the equation with the question that we're working on. In this first one, we're looking at major arcs. Remember, minor arcs have 2 letters, major arcs have 3. Minor arcs are less than 180, major arcs are more than 180. So I'm looking for a major arc that contains the point J. Now, if I look at the answers here, I have a point J there, a point J there, no point J here, so I'm wondering about that, and a point J here. J's there, J's there, J's there, J, J, J. There's no J here, there's no J here, and there's a J there. There's a J, there's no J here, there's no J here, or here, or here, or here. But now what I got to make sure of is knowing that these are all minor arcs, and I'm looking for major arcs, okay? But one of the things I want to make sure you recognize, that if I'm looking at the ones that don't have J, KLH, if I go KLH, this is a semicircle that truly does not have J in it, or LHK. If I go through LHK, that does have J in it. That contains J. But because this one doesn't have a J, I wouldn't select this one at all. Okay, this one has 3 J's, but it's not all the major arcs that contain J, because if I look at LHK, and I'm talking about LH to K, it contains point J. So A is my best offer on this. So make sure you recognize that it's not just the arc with J in the name, but it has to contain J during the arc as you go over it. Interesting. In question 2, I'm looking for the name of a major arc and the find its measure. So I have a minor arc. I have minor arc AB, and if I take 360 and I subtract it, that minor arc AB, from 360, I get myself 310 degrees. So now I'm looking at that major arc, and my major arc here can be named 2 different ways. I can name major arc ADB, or I could have said it was major arc BDA. Remember, major arcs have 3 letters, and it has the start letter and the ending letter. And it tells you which letter it goes through on the way to get to the end. So when I'm looking at this, I'm looking at ADB or DBA. Okay, so these 2 are the ones that I'm considering, but it's a 310 degree major arc. So my answer should be C. In problem 3, I'm asked to find the length of XPY. And when I'm looking at the length of XP, I'm looking at the arc length. Now let me write out the equation that we're talking about. We have arc length, which is the arc of AB over 360. And because it's arc length, it's 2 pi r. We're talking about circumference, not area. So I'm looking at an arc length of XPY, and XPY is this length. So I've got 270 degrees, which is 360 minus 90. Okay, and I'm supposed to leave my answer in terms of pi. So now I've got 270 of 360, and my radius is 8, so it's 2 pi 8. So now I can get this down to 3/4 of 16 pi. This ends up being 12 pi. And that is in meters. So I go over and look at my selections, and I have 12 pi meters. In question 4, I have a 105 degree sector, and they want me to find the sector area. Now it's very similar to the last one, but if I go sector area, and I have my arc of AB divided by 360, that's pi r squared because it's area. Okay, Now I have 105 degrees, so they want me to find the area of the 105 degrees. So I have 105 degrees over 360, and my radius is 9. So I have 105, 360, 81 pi. So they didn't tell me to put it into the nearest tenth here. They got me having a nearest tenth, so I can put this in my calculator. 105 divided by 360, okay, times 81 times pi. Okay, and I'll be able to come up with 74.2. So this is equal to 74.2. And my units on this, are inches squared. So now looking at that, 74.2 is my selection D. In question 5, I'm asked to find the area of a sector with central angle 180. Okay, now keeping in mind, let's bring up a picture. Every time they don't give me a picture, they're making the problem harder. This is a 180 degree central angle. It's a diameter, and the diameter is 5.6. Round to the nearest tenth. So I'm talking about area of a sector still. So I've got to take half of 5.6 to find the radius, and that'll give me 2.8. And I'm still working with arc length. Excuse me, sector area we're working with. So I've got sector area. It's equal to the measure of arc AB over 360, and I've got pi r squared. So I have 180 over 360. That's just half my circle, and I've got 2.8 squared pi. Now, if I put this in my calculator, I've got, just to make sure that my 5.6 divided by 2 was 2.8. Okay, so now I've got 0.5 times 2.8 squared, because it's area, times pi. That's going to come up at 12.31. Okay, so my selection's here. I'm just going to finish it out that it is 12.31, and that's centimeters squared. And it says 12.3 rounded to the nearest tenth. My last one here, or my number 6, I should say, is asking me to work with what is called as the, I want to find this shading region here. Okay, to find that shaded region, I'm going to find the sector area. Okay, so I'm going to use sector area, arc length, AB, over 360, and remember it's area, pi r squared. I'm going to subtract a triangle. Now, because this formula I'm going to show you works every time, I'm going to use this. I know this triangle is base times height divided by 2. It's really easy. But I also want to show you this formula. So you want to make sure that you've got that going on. And that should equal my sector area left over, my shaded region. So now I'm looking at 90, 360, pi 9 squared, minus 1/2 9 squared sine of 90. Should be able to pop that up. And I've got 1/4. 0.25 times 81 times pi minus 0.5 times 81 sine of 90. And that should give me 23.1 as my final answer. And I'm going to check my, I've got feet squared. It's 23.12 actually, and I'll be able to pop that in there and show my answer. So those are the questions that you're asked to go through for 10.6 and 10.7. If you have any questions, make sure you review them and talk to Mr. Bloom during class or before and after school. Have a great day. Hopefully everything's going well.